Howdy, folks. My name's Peter Hansons. Welcome to the DataEng meetup here in Australia, the November edition. Welcome. Hope you're staying safe and well, enjoying your newfound freedoms after being, in, lockdown or whatever for so many months. We will be getting back to in-person meetups soon enough, probably in the next couple of months, perhaps in the new year. Looks to be the most likely timeline at the moment. So stay tuned for further announcements on that. But the online format's been really good so far over the last kind of 18 months, even though we've managed to squeeze in a few in-person meetups. It means that we can get speakers from all over the globe if they're willing to stay up late enough to sort of fit in our time zone. We've got two speakers, one dialing in all the way from Mexico, an avid scuba diver, Danny Leybzon. He's a MLOps architect at WhyLabs. He's got an awesome talk for us in regards to sort of where data engineers can play in the MLOps space, which is pretty cool. And then our second speaker is Banu Jamal, head of pre-sales at PingCap. He's going to be taking us through making a HTAP database a reality. HTAP being that sort of combination of OLAP and OLTP. So that is going to be a fascinating talk. But like I said, first up, we have Danny Leybzon. He's going to take us through Savior model from degradation with data logging. That sounds really, really cool and right in the realm of sort of, I guess, a data engineer's remit. So Danny's worn many hats, all of them related to data. He's studied computational statistics at UCLA, and just loves, all the awesome stuff like rock climbing, backcountry, backpacking, and skiing, etc. Sounds like me and him could be pretty good mates, to be fair. So welcome along, Danny. G'day, mate. How's things all across there in Mexico?
Things are good here. It's getting late, but I'm so excited to talk to everyone who's gathered for this meetup and to share what we've been working on. I don't know if the appropriate term is across the pond, because I guess that refers to the Atlantic, across the Great Divide, maybe, between our hemispheres. Yeah, I'm excited to share what we've been working on and show the data engineers in this group that actually they've got a really important role to play in the MLOps and in the AI space.
Sounds great. I might leave you to it then, Danny. Looking forward to it. Thank you.
All right. Thanks for the introduction, Peter. So like Peter mentioned, my name is Danny. I'm an MLOps architect here at WhyLabs. What that means is that I do a lot of things, but one of the important roles that I have is evangelizing the vision that WhyLabs has around machine learning and more broadly around data ops. And what I'm going to be trying to convince you of in today's talk, in today's conversation, is that although I'll be talking a lot about machine learning models, fundamentally what we're going to be dealing with all the time is data. And hopefully by the end of this talk, you'll come away understanding that data engineering, and data logging are really key to the MLOps pipeline and really key to being able to have machine learning models in production. So let's start by going over kind of an agenda, a table of contents for what today's presentation is going to look like. First, I'm going to review a workflow, just kind of get everybody on the same page about what does it mean to build a machine learning product, how do we deploy machine learning in production, and from there, I'm going to talk about what might be referred to as model monitoring and observability, but is more properly thought about as data monitoring and observability. From there, I'm going to talk about this very simple truth that monitoring requires logging, and then present to you an open standard for data logging, WhyLogs, and finally wrap up with any kind of Q&A that we might have at the end of the session. So let's start off by talking about the ML workflow. So those of you who are already familiar with the ML and the MLOps space might be familiar with flow diagrams like this. They all look a little bit different. We've got one on our website, but to be honest, I kind of prefer this one on Martin Fowler's website. This comes from an article called CD4ML, Continuous Delivery for Machine Learning, and it breaks down the various components of the ML workflow into code, model, and data, and into the various steps involved in building a model, productionizing it, testing it, deploying it, and then monitoring and observing that model. So as you can see, this really follows the same general workflow that you would have for any other kind of software application, right? You build a software application, you productionize it, you test it, and then you deploy it. And after you've deployed it, you need some kind of tool to monitor it and to observe it. Machine learning shouldn't be any different, and machine learning applications shouldn't be any different than other types of software applications in terms of their need to be monitored and observed to make sure that they're still able to perform. The challenge comes in that machine learning models are a different type of application than classic software. They're less predictable, they have less stable inputs, their outputs can be very challenging and can have very complicated relationships to their inputs. So monitoring and observing a machine learning model is actually pretty radically different than monitoring or observing any other kind of software application. So, okay, we've talked about what monitoring is and how it fits into the ML workflow, but the question that I imagine most of you are asking is like, oh, okay, but why? Like, who cares, right? What happens if I don't pay attention to how well my model's performing? Well, I've got kind of a silly example here on the right side of the screen, right? This tweet by Andreas where he's pointing out this ridiculousness, Amazon recommending bell peppers because they're out of stock for flowers. Now, any human being looking at this would say, wow, that's kind of a dumb recommendation, Amazon. Why are you choosing to present bell peppers instead of flowers? But the key observation here is that machine learning models, rather than humans, are sending out these recommendations, and machine learning models are fallible. Right? We can teach a machine learning model how to think about the world, but it will always be limited in scope to the things that it's actually learned about. So the observation on this slide is that if you're not keeping an eye on your model in production, your customers are sure to notice, which is why it's important to be proactive rather than reactive to potential degradations in performance of your model, and to be able to observe and monitor your model as it's being deployed in production. One really key observation from Cassie, who's a chief decision scientist at Google, is that the world represented by your training data is the only world you can expect to succeed in. And there's a lot of different ways that the training data can differ from real world data. I'm not going to dive into all of those different types of deviations between training data and production data, but if you look up training serving skew, if you look up semantic drift, you'll see examples of different ways that your model can degrade in performance after it's been deployed to production compared to its performance in the sandbox. So while we can have, a beautiful model that a data scientist or a machine learning engineer slaves away at trying to get the accuracy to be really, really high, when it gets deployed into production, if we're not carefully monitoring the data being fed into the model and the predictions being made by the model, then we're not going to be able to actually monitor the performance of the model, and we're not going to know how well it's able to serve its recommendations or classifications or regressions, whatever it might be. So hopefully now the data engineers, the machine learning engineers among you are sold on the concept that, okay, it's important to monitor a machine learning model. But okay, how do we actually do this? Sounds nice, Danny, but let's get into it. So I'm going to present not exactly a novel thesis, but one that I think a lot of people find kind of counterintuitive, that there is no such thing as model monitoring and observability. There is only data monitoring and observability. As I mentioned earlier, rather than trying to look into and introspect the black box that is a machine learning model, you can get really effective cues about the performance of the model by looking at the data being brought into it, comparing that data against the data that the model was trained on, and then also looking at the predictions being made and the distribution of predictions being made by the model. And if you see changes in the predictions being made or on the incoming data, that might be a sign to you that your model is no longer able to represent the real world processes that are generating the data. So this is all to say that model monitoring and data monitoring are actually the same thing. So if we think about what types of questions people might ask about how their model is performing, they can think about, should they be worried about data drift? What did their training data look like? Was the input data different today versus yesterday? How much did it actually shift? How much did it shift over a longer period of time? What you'll notice in all of these questions is that they're actually not questions about a model, right? The word data appears in all but the first question, because realistically, in order to know the performance of the model, what we really care about is the data being fed into the model. Okay, so now we've established that model monitoring actually means data monitoring. So when I say monitoring requires logging, we can infer that data monitoring requires data logging. And let's talk about what data logging might look like. Well, coming into the world of MLOps, it can be useful to look at our brothers and sisters in the DevOps community and see what it is that they're doing, because they've been at this for a little bit longer than we have. So classic monitoring and observability questions in DevOps might be, is my application performing well? If not, what about the application isn't performing well? And then the follow-up, what can I do to ensure that it does perform well? These questions map really nicely to the MLOps space, right? We can ask, is my model performing well? If not, what's causing my model to not perform well? And then what can I do to ensure that my model will perform well? Right? We can see that there's a really clear parallel between the world of DevOps and how they think about monitoring classic software applications and the world of MLOps and how we think about monitoring ML or AI applications. Digging a little bit deeper into the way that people in DevOps think about monitoring, a key initial step to monitoring a system in the DevOps world is logging. And logging in the DevOps world usually means system logging or application logging, right? It's generating stacks, traces, maybe raw text logs, all of these different examples of artifacts that are created by an application or by a system that's monitoring the application to be able to monitor those logs to monitor the application itself. So examples of logs generated or metrics generated by a classic software application might be something like load, the response time, the amount of CPU being consumed, the amount of memory or storage being consumed, the amount of I/O, so the amount of read-write happening. Then conversely, in the world of MLOps, if we think about what kind of logs we might want to generate for an ML or an AI application, we really should be thinking about data logs. And what I'm going to be presenting to you is kind of a novel hypothesis within the world of data logging, because people have actually been doing data logging for kind of a while. But they've been using a technique called sampling, where they pull random examples of data from their entire data stream and store just those samples, which obviously doesn't give you a full view of what the data set looks like. What we at WhyLabs do, and what the open source tool WhyLogs does, which I'll tell you about in a minute, is it creates profiles, which are statistical summaries of data, these distributions of data that allow you to understand what does the data look like without storing the raw data, which has a number of advantages that I'll get into a little bit later. But to finish off this slide, what these profiles allow you to do is to monitor the performance of the model, to monitor missing values, the cardinality, the data type, the distributions, the top K items, and it actually also allows you to monitor unstructured data. So data like images, like text, like audio, like video, all of these different examples of unstructured data, which we're able to profile with WhyLogs. So if we're asking the question, how do you test, how do you monitor, how do you debug, and how do you document data, I present to you that you want to have three key properties of a data log. You want it to be descriptive. So that is to say, you want it to tell you about what the data looks like. You want it to be lightweight, right? We don't want to be moving an entire data set around. Those things get pretty big. I mean, they're getting into the petabyte, the zettabyte scales at this point. So we probably don't want to be trying to transfer that over a wire. We want to use something lightweight that we can easily ship from wherever we're doing the logging to wherever we're doing the monitoring and observing. And then we also want it to be mergeable. Now, mergeable is a really interesting property of a log. It means basically that we could take two logs and merge them together in order to create one new log that shares the information of the two prior logs. And although this might be a little bit abstract and confusing right now, I'll dive into it a little bit later in today's presentation to talk about why this is a really important attribute of a data log. So you might imagine, and if you were paying attention earlier, you might have heard that the reason that I'm talking about these attributes of a data log and what one might want to see in a data log is because we've actually built one. We've built a data profiler, a data logging tool called WhyLabs, which allows you to generate these profiles, these logs, these statistical summaries of the data set, and therefore allow you to monitor not only ML applications, but actually entire data operations applications. So you can monitor your data pipeline, you can monitor your data at rest in a database, whatever you might be doing with data. If you want to assure and ensure the quality of the data, you'd be able to do that with monitoring via logging it. If you want to check out this library, you can go to bit.ly/ylogs. I'm going to dive into a little bit more verbose description of what the project actually looks like now that we've set up the theory behind what we think a logging tool should look like. So you can imagine, if you don't have a logging tool already in place, then your data is ephemeral, right? It's constantly changing, it's moving, it's shifting, it's streaming through. Even if it's batch, you've got these changes over time in data. And if you don't carefully hold on to your data, or at least carefully hold on to logs of your data, you're not going to be able to track those changes over time. Now, WhyLabs allows you to generate snapshots of data, right? These statistical summaries of data that enables you to see changes over time so that you can do stuff like monitor the performance of a machine learning model, or alternatively monitor the quality of a data pipeline that you have set up. So another important key thing to emphasize about WhyLabs is how easy it is to get set up, right? You can pip install it really easily, just pip install WhyLabs. If you're operating in Spark and in a Java environment, we've got a Maven repository that you can download it as well. And it literally takes one line of code to generate a profile for a Pandas data frame, for a Spark data frame, for an image, whatever kind of data you've got. We can create a profile for it with just a couple of lines of code. It's really, really easy to generate these profiles, and you can do a lot with them, as we've been talking about so far, and as we'll be talking about even more. So I talked to you earlier about this concept of sampling versus profiling, right? Because a lot of the time people come to us and say, why would we want to profile our data? That sounds convoluted and complicated. Why don't I just either store the entire data set or take samples from the data set and just store those samples? Well, as it turns out, storing entire data sets for extended periods of time, and especially trying to analyze those entire data sets, can be really computationally inefficient, right? Which is why we talk about logs wanting to be lightweight. We also want logs to be descriptive, and that's why sampling isn't really an effective measure. Now, if we think about things in terms of statistical distributions, and we think about sampling from a statistical distribution, then for some statistical distributions, sampling works quite well, right? If we imagine that our data is normally distributed, if it follows a Gaussian curve, then a regular sampling technique will give us a pretty good idea of the parameters of the normal distribution and allow us to have a strong idea of what the process that generates the data looks like. However, if we have an exponential distribution, which is actually in some ways more common in natural or real-world processes than normal distributions, in the case of exponential distributions, sampling proves to be very, very ineffective, as is demonstrated on the graphs and the charts on this slide. So if you imagine an exponential distribution, which has kind of a fat head and then a long tail, if we're sampling, we're likely going to be missing a lot of the infrequent, the uncommon values in that long tail, and we're not going to be able to create a realistic model. We're not going to be able to accurately capture the data distribution of an exponential distribution. And that's really all these graphs are saying, right? If you look at this blue line, which represents the median error for sampling, and then conversely, if we look at this brown bar or the maroon bar for the same charts, we can see that there's a much lower median error when we try to recreate a distribution from profiling versus sampling. So as we can see, profiling is a more accurate way to capture distributions, and therefore it's a more descriptive way for us to be able to log our data. Now, as we've talked about, we want our logs to not only be descriptive. I mean, the most descriptive thing would be literally storing the raw data. We also want it to be lightweight. So to prove the lightweightness of WhyLabs, we actually ran a benchmark where we took a number of different large data sets, right? One in 1.5 gigs, one for 75 gigs, and we ran it through the WhyLabs profiler. These data sets had different numbers of entries, 2 million, 10 million, 175 million, different numbers of features. But the end result is that after they'd been profiled with WhyLabs, they only needed 14 to 15 megabytes of data of memory to profile. And then at the end of the day, they actually were able to be profiled and stored as those data profiles with only a couple of megabytes, as opposed to these gigabytes that were required to store the raw data. So by having these really lightweight log files that we're able to send around, rather than sending around the raw data, we're able to be a lot more computationally expensive in terms of all of those important things like compute, like memory, like storage, like IO, rather than having to deal with raw data. Dealing with lightweight profiles enables us to scale our system. Now, let's talk about the third key attribute of a data logging tool that I talked about earlier, which is mergeability. Now, if we imagine generating a data profile for yesterday, we can think about the data distribution for some property that we're tracking yesterday. And then if we profile data for today, we've now created two different profiles. Now, this is cool and useful if we want to compare today's data versus yesterday's data. But what if we want to compare this week's data versus last week's data, and we've been storing profiles in daily form? Well, if we've got daily profiles, it won't be possible to compare them to last week's data unless we're able to merge all of these discrete 7 days of daily profiles into a single weekly profile. So mergeability, as it turns out, is kind of a table stakes necessity for a data logging, a data profiling or data logging tool, because it enables us to do comparisons at different levels of granularity. It also enables more use cases and enables WhyLogs to be used in a number of different environments. One example of an environment where WhyLogs really flourishes is in a distributed system. Right? If we imagine we've got an application running across multiple different servers, we've got these different servers all generating their own data, but actually there's kind of a random distribution of data between these servers. We don't care about, whether the data comes from server 1 or server 2. They should just kind of be the same data. Then we'd want to be able to merge the profiles from these different servers into a single profile. Similarly, mergeability is really important for streaming architectures, right? If we think about having like a Kafka pipeline or a Kafka stream, then it's important that we be able to take in new messages from the Kafka stream and merge them automatically into the existing profile, instead of having to create a separate profile for every single batch or micro batch in the Kafka stream. Right. So in this way, mergeability, although again, it kind of sounds like a table stakes or even like an obvious thing that of course you'd have to have, is a really key feature of a data logging and a data profiling tool, because it enables distributed systems and streaming architectures, both of which are obviously very important in the world of data engineering, as well as very important in the world of machine learning and MLOps. Another cool thing about WhyLogs is that it works with a lot of different tools and integrates with a lot of different popular technologies. So I mentioned that we work with Apache Spark, that we work with Scala. We also work with Kafka. We've got a large retail user who uses us to monitor Kafka streams in real time and ensure the quality of the data being sent through their Kafka streams. We integrate with pandas in Python, NumPy, MLflow. This is by no means a comprehensive list, but as you can see, we've got a lot of different places that we can generate these logs from and generate these profiles to enable data and ML monitoring across a number of different applications. So in answer to our previous question of how do you test, monitor, debug, and document data, hopefully we've all now come to the conclusion that we can do these things with WhyLogs, this open source profiling and data logging library. Now, I hope that you all will navigate to our GitHub, give us a star, try us out. But if you wanted a little bit more incentive to be able to do that, I'm actually happy to offer you guys some swag. It might be a t-shirt, it might be a water bottle, it might be a stress toy. I can't tell you which it'll be yet, but if you go to the 3 links that I've listed here, 1 to star our project on GitHub, 1 to join our community Slack, where you can ask myself or the engineers working on the project any kind of questions that you might have, and then you submit a form that contains the email that you used to join our Slack, your GitHub handle that you used to star us, and then a good mailing address for us to send the swag. I will personally mail you whatever kind of swag it is that we end up going with. Hopefully you end up doing this without the need to get, yet another vendor t-shirt, but maybe this is the thing that gets you over the edge to get involved with our project and try us out. So thanks for taking the time. As I mentioned, my name is Danny Leybzon. If you want to reach out to me, my email is danny@whylabs.ai. My handle on most things is DLEYBZ, so you can message me on Twitter. If you want to get involved with the project, you can check it out on github.com/whylabs/whylogs or bit.ly/whylogs. And then if you want to join our Slack community, you can do it at join.slack.whylabs.ai. So that's today's presentation. Peter, are there any questions? Does all of this make sense?
Yes, that all does make a lot of sense, Danny, and thanks so much for the presentation. Sometimes we're a bit slow getting out of the gates at lunchtime in terms of questions from the audience, but I can sort of get a few in while perhaps the audience sort of preps up their questions. But say, for instance, like, what are some of the things that you've seen from customers and the community using YLogs and YLabs? So you've got a machine learning model that you've put into production, and I guess that the idea is sometimes that model doesn't exactly always sort of produce the outcomes that you would like, or you're just a little bit unsure of what results that model's returning. And sort of are there any sort of like interesting, I guess, cases where sort of customers or community members have gone, oh gosh, thankfully I put that into in place and got some visibility over it?
Yeah, I mean, there are definitely some examples of people picking up on training serving skew, as I had mentioned earlier, where they take a model that they've trained in their sandbox, and when they deploy it in a real world environment, they see that the data coming in is totally different, and then they start digging in and looking at the recommendations being made. One particular example that I'm thinking about when I talk about this is there's a large retailer in the US who might also be prominent in Australia. I'm not sure, who uses us to monitor their cameras in their store, right? So they take these profiles generated by looking at the images from these video cameras. They're not ever looking at the raw images or the raw video itself. They're looking at these profiles that are generated, and they're seeing the quality of those images being generated over time. So they were actually able to see that a machine learning model that they had trained to detect potential theft or shoplifting had a racial bias in it. And they were able to pick up on that racial bias and pick up on the fact that they needed to go back and retrain their model with fresh data by using YLogs and by using the proprietary platform that YLogs can connect to YLabs.
Yeah, that sounds like really important. So I guess monitoring your models can also have, I guess, like an ethical sort of focus to it as well, and lots of considerations to think of there. And so you've just got you can just pip install YLogs and sort of get yourself up and running. If you're in the Kubernetes ecosystem, is it just like, have you got a Kubernetes operator or something like that, or is it just kind of the preferred method just to go ahead and get yourself a subscription to YLabs or something like that?
Yeah, in the situation that you're running within Kubernetes, you could, similarly do a pip install or install through Java. We don't have a Kubernetes operator quite yet, mostly because the situations that we see where people are using YLogs is running alongside wherever they're doing their data processing or wherever they've deployed their machine learning model, right? And most of the time, people are doing their ETL with something like Apache Spark. So we've got this Spark integration, and most of the time they're serving their model with Python. So we've got this Python integration. But one of the cool things about being in a small, fast-moving community where we're developing our open source very quickly, one cool thing about that is that if there's a need for something, it's very fast to get developed. If somebody comes and says, hey, I'd really like to use YLogs, but I need to be able to deploy it in my Kubernetes environment, it's very easy for an engineer to go, okay, we'll set it up in a Kubernetes environment for you.
Yeah. Yeah, no, that sounds amazing. And so, just to run me through the architecture again. So you've got like a logging service that you install with your models and data collectors and things like that. But then you've got like a logging collector as well. Is that open source, or is that more the WhyLabs service? Is it?
Yeah, that's a great question, actually, Peter. And I didn't come on here planning to talk about WhyLabs. I was really going to focus on the open source, but man, you queued me up to talk about it, so I'm going to do it. So WhyLogs is the open source, right? Which is kind of this AI telemetry in this diagram. It allows you to generate these profiles, these logs, and it runs alongside wherever you're deploying your machine learning model, wherever you're doing your data transformation, your ETL, whatever it might be. And then what you choose to do with those profiles is up to you, right? You can analyze them with WhyLogs itself. We've got this profile viewer that runs inline in Python. You can send them to like a classic database. You can send it to like Prometheus and visualize it with Grafana if you want to deal with setting up those tools yourself. Or you can send it to our proprietary AI observability platform, WhyLabs, where you're able to take in those profiles and monitor and observe on those profiles to get key metrics about the performance of your model and get alerted if your model actually degrades in performance. One of the really cool things about WhyLabs, in addition to taking this very classic DevOps approach and approaching it and applying it in MLOps and DataOps, is the fact that you can actually try it out and sign up for free with no credit card or anything like that required. You just come in, you make an account, never have to talk to a salesperson, and the first data model, the first ML model, the first data pipeline that you monitor, you actually get to monitor it for free without ever paying us. And you get all of the features of the platform for a single model, again, with no credit card, no subscription, nothing like that. Just by providing us your email and creating an account. So if you're interested and you want to see what this tool can do, you can try it out for yourself and see whether it's getting value before even engaging with anybody from our team.
That sounds awesome. Great sales pitch. But like, and totally cool to sort of, plug a product and stuff like that. If it's adding value to data engineers' lives and stuff like that, then that's an awesome thing, isn't it? Saving a lot of time. So, yeah, pretty keen to sort of give WhyLabs a shot and just, check it out. So, like I said, Danny, really appreciate you. Please excuse my 2-year-old son from wanting to get a bit of camera time. Really appreciate you joining us today. I guess you're going to give us a reminder of that GitHub repo and the Slack to join, is it?
That's right. Yeah, just one last shout out. If you want some swag mailed all the way from the United States, we'll send you something if you join the community Slack, start the project, and then submit a form.
Awesome. Well, really appreciate your time today, Danny, and yeah, looking forward to that swag. Cheers.
Cool. Thanks, Peter.
Bye. Okay, so up next we have Banu, who's joining us all the way from Singapore, which sounds pretty cool. I'm guessing it's nice and warm over there. Probably really enjoying the lead up to summer. Not too long to go till the festive season, to be fair. So you're going to take us through making a HTAP database a reality, which sounds really fascinating. I think, one of the biggest challenges in data engineering is shipping data from an OLTP database through to a OLAP database for sort of, data processing and the like. So not having to do that must be a pretty cool thing. So Banu is currently head of pre-sales at PingCap. I'm sure he's going to take us through that. He's got 20 years of experience in big data, data warehousing, and project lead managing and consulting. So that's awesome. Work ex like VMware, Pivotal Software. So sounds like you've got a bit of experience there. Welcome to the meetup. How are you going?
Hey Peter, thanks. Thank you, and I think first of all, thanks for giving us the chance to come and speak on this amazing engineering group. It's a privilege to be here. And yes, so it's been a great journey, in the big data world, and obviously now I'm kind of between the big data and the fast data. So I think it's a great time to be in.
Yeah, well, welcome. Guessing you've got a few slides that you'd like to take us through. So if you'd like to share your screen, and I'll drop off and let you take it away.
Yes, I'm just sharing the screen. Just give me a minute. Okay, are you able to see the full screen?
Yep, that looks great. I'll leave you to it. Thanks, buddy.
Thanks, Peter. Hi, everybody, and once again, thank you. I think it's a privilege to be here and talking in this session. So the agenda for today is HTAP, and just a quick introduction before I start. So I'm heading solution engineering for a company named PingCap, and I cover the APAC region. And my past experience mostly has been in the space of big data and data warehousing and data lakes. And I've kind of worn different hats in the IT industry, from project managers to consultants to pre-sales to sales. I think I've kind of tasted every role, and it's great to be into this data space. I think I'm really passionate about about the data, whether it be fast data or big data, and especially the new SQL databases which are now coming up, and would be probably the next wave I foresee. Like how Hadoop was a wave for big data, probably new SQL databases would be the new wave for for fast data. Right. So maybe let's get into this session. So I'll be talking about the what, the why, and the how about HTAP, right? And it's HTAP is something which probably some of you may know or most of you may know, and this is the term which we'll basically be focusing on today, right? So let's start with the what is HTAP, right? So now whenever we talk about new terms coming up, right, different analysts in the industry would be talking about will be coming up with these new business terms. So if anybody has heard about translytical before, it actually means transactional and analytical, right? So there was a product company about 5 to 6 years ago which came up with this term called translytical. I heard a word called HOPE, which is basically the hybrid operational analytical processing. That is what it meant. So these are just workloads which enterprises talk about. And then HTAP probably became the most popular and the most adopted term, which is hybrid transactional analytical processing, right? So these are different words in industry, and some may get confused as to why are these different terms existing, right? Obviously, they all mean the same. Right? They all mean the same. What they basically do is they have that ability to process transactional and analytical workloads on one single system, right? That's what they mean. So then let's get into some more details of what is HTAP. Right. First of all, this word was invented by Gartner, and hence I think this is probably the most adopted term these days. And HTAP is basically a very, very simple concept. What it does is HTAP basically means a system which can process both transactional processing workloads and analytical processing workloads on one single system. Now, this has been a challenge for a very, very long time, right? Probably HTAP is something which is not new. We would have heard HTAP even 10 years ago, but I think there was no successful way to actually architect this and make sure that you're getting good performance out of the HTAP systems. Now, when we talk about the combination of two, when we talk about transactional processing systems, right, the typical nature of these systems are that they are highly concurrent. They expect high concurrency and consistency. Right? A simple example could be, one going to an ATM machine and withdrawing some money from the ATM, right? The moment they put their card and take out the cash, there'll be a transaction which will happen. The ATM machine would tell them, this is what the balance is. So, likewise, there'll be hundreds and thousands of users who will be using an ATM machine at the same time, same hour in the same city, right? So imagine the number of concurrent sessions which will be happening, right? These systems expect high throughput. Enterprises would say, I want to read and write data. Let's say I want to write data. I want to write 5,000 queries per second, or I want to write 10,000 queries per second. Likewise with the reads. The underlying storage is basically row formats. When you store data on the transactional processing systems, the data is stored in a row-oriented storage, right? And this is obviously beneficial because you are updating this data in real time. There's updates, there are deletes, there are new inserts which are happening on these systems every second or every millisecond. Right? And transactional processing systems are always taking care of current data. Right? So whatever data has been produced would be ingested into the system, almost in real time. And then when we talk about an analytical processing system, the nature of analytical processing system is very different than what I just explained on transactional processing systems. Analytical processing is something which is, the queries would be lesser, the concurrency would be lower, and which basically means that there'll be specific business users who will be accessing the system, for analyzing the data. These could be enterprise business users. The throughput would not be as high as what is in transactional processing. So you're not obviously expecting to run 2,000 queries a second, because now the goal for you is to basically analyze your data, within your organization. The underlying storage is different. You store your data in a columnar format compared to transactional processing, which stores data in a row-oriented storage. If you've heard about all these big data technologies, with the likes of Teradata, you talk about Netezza, Greenplum, Vertica, all these technologies store data in a columnar format. Because when your data is stored in a columnar format, the read access is more faster, and since your reads are faster, your analytics gets a boost, and you get more performance there, right? And I think finally, for analytical processing, you are talking about historical data. You're not just talking about last 1 week or 1 month of data, but you're probably talking about last 5 years or last 10 years of data, right? So if you see, both these are very different, and to have a system which caters both these workloads has been challenging, right? So now let's get into why HTAP. Why do we need HTAP? So a typical scenario would be, consider, let's take a use case, right? Let's see that an enterprise wants to do analytics on an online order data. With this order data could be, let's say, generated by an e-commerce website. Right? So if you have that, you will first need to have separate platforms, one for your online transactional order processing and another platform which would be doing your analysis, right? And then for analysis, you will always have to move data from your transactional processing to your analytical processing databases, right? When you move this data, obviously moving this data itself is very, very expensive. When I say expensive, means that you're obviously losing time, because of the process. So a typical architecture, which you would generally see in enterprises, would be something like this, right? It might not be exactly like what I'm saying, but at a very high level, the idea is this: that enterprises would have OLTP systems, and they would always have the need of analyzing those OLTP, the data in those OLTP systems. So in this case, let's say the data is generated, and the data producers have sent their data almost in real time. The OLTP systems have absorbed that data. The data is now existing there. What is the next step for enterprise? The next step is they want analytics. And they want analytics because they want to find out, they want to take out value of the data which they possess. So typically what they would do is they'll create an ETL process, and they'll move this data to some centralized system which can perform analytics. So for reference, for example, I've just taken Hadoop as a reference here, but this could be any analytical system. Now, once the data reaches Hadoop, in this case, there are analytics which are performed, the data is refined, and now you have a copy of data which is already analyzed, and you're ready for exposing this data to the end users. But the next challenge is you can't just expose this data directly out of Hadoop, right? Because Hadoop is not good in throughput, as I was saying. This is an analytical system, so it will be low throughput as well. And if there is a data application which wants to consume this data, one way to do this could be that you push this data to a layer, let's say another OLTP layer. It could be HBase running on Hadoop, and then you open up, and you expose that HBase layer to a data application. So then in that case, there's another ETL which is happening. There could also be scenarios where the data application wants to access data directly from the OLTP systems. So in that case, one way to do that could be you flow the data using, for example, Kafka, which is the messaging bus. You stream that data to maybe HBase, right? And then from HBase, you expose it to the data application, right? Obviously, there could be a lot of other ways to do it, but in a crux, you have to move data out of your OLTP system to an analytical system, right? And then you will have to face the challenge of how do you expose this data to the data application, because your data application might expect high throughput, right? So this is the typical kind of an architecture. And if you see on the top right, for example, if your data is on OLTP system and there's a set of snapshot of data which has been loaded at 10 a.m. in the morning, and your users want to analyze this data, they'll not be able to analyze it then and there, right? So they'll have to wait for this data to be moved using an ETL process. So just for an illustration, if let's say it takes 3 hours for an ETL process to complete, and your data is moved to Hadoop, your analysis can be done at 1 p.m. Right? This is just hypothetical, right? It could be 1 hour, it could be 30 minutes as well, but in certain cases it could even be 1 day. Now, what is the HTAP approach? Right? So the HTAP approach is to have a system which gives you the high throughput, which ensures that there is data consistency, because that is probably one of the key points of a transactional processing system, that you need to provide consistency when you are loading data. If you've heard about NoSQL technologies like with the likes of MySQL or Cassandra, an example, these are great in high throughput, but they do not provide consistency, because there are no SQL, and it's very hard to manage that consistency. So a HTAP system should be such that it provides you that consistency. It provides you that distributed storage so that you can keep storing more and more data, whatever is coming in from your transactional workloads, right? And at the end, it should give you something where you can perform analytics on your system, right? So on the left-hand side, there are data producers. They're pushing in transactional workloads. These transactional workloads, let's say, could be millions of records on a daily basis with high write throughput, high read throughput, and very frequent inserts, updates, and deletes, right? So there's a lot of data manipulation happening. And at the same time, there's analytical workloads, where there's advanced analytics happening. There are complex aggregations. There are multiple tables which are being joined, and there is a need for real-time data access, right? All of this can be achieved on a single centralized system which supports both these workloads. And what benefits do you get? There is no ETL. You get rid of the ETL process completely. You enjoy the high transactional throughput, which generally a transactional processing system gives you. And then you can perform analytics in seconds as opposed to hours or days, in my previous example. I think those are some very, very key benefits of having an HTAP. So again, on the top right, if a data is ingested at 10 a.m., it can be analyzed at 10:01 a.m., for example. So that's why we call it as a real-time data analytics for HTAP. Right. So just to put this in context, I thought I'll just talk about one of the use case. So I picked up a use case from a gaming customer. Right? So if there's a gaming customer, what would he need, right? So the first thing he would need is he would need a system which can store data for all their games, under their banner, right? A gaming enterprise would have different games, which they run, and generally, if the behavior is that for every game they will try to create one database at the back end. Right? But if they do that, then there is a challenge, because now they'll not be able to kind of correlate gamers and take out and do analytics and find out which gamer is playing how many games, right? Because your databases are isolated. So the first thing they would like to do is create a unified customer center, where you are talking about a large number of players in gaming companies having years of histories. And if players are fragmented in different databases, there's no unified customer experience, right? So you have the centralized system. You move all the data which has been produced by different games into this centralized system, right? So this is a transactional processing use case which they have created. Another requirement from a gaming customer could be, with finding out what are the sentiments of the players who are playing the games, right? And this is very, very productive for enterprises, for gaming customers, because once, generally when somebody tries to when they start playing a new game, probably they'll be interested in that game for first few weeks or month. They will try to buy additional coupons, tokens from this game. But as the time goes, maybe their interest start getting faded, right? So this is where sentiment and insights and sentiment analytics come into place. So an algorithm which can find out the sentiments, by finding out what are the different activities this particular gamer is doing, is a great insight for a gaming company. And if you have to run both these workloads together, you would need an HTAP system, because if you are running two isolated systems, one which is managing transactional and one which is managing analytical, then you will not be able to come up with those real-time insights. And you will not be able to send, let's say, some gift coupons to gamers or some discounts to gamers in real time and keep them, stick to your game. So a typical architecture for a gaming customer would be something like this, right? So you'll have, different data producers, in your in-game purchases, all that information flowing in from, let's say, Apple, store or Google Play. You will have multiple ad interactions to see, how many gamers are getting attracted with the ads you're generating, right? There could be, data generated from gameplay, from, let's say, sources like Unity or Unreal Engine. But eventually, what you're doing, you are bringing this data, or you're reading this data, and at the end, you are kind of storing it in a real-time HTAP system. And if you see, you are now exposing this HTAP system for dashboards. These dashboards is something which a gamer sees on his mobile app or on his desktop, right? There could be a provision of doing ad hoc queries on this. This is more for analysis, more for enterprise users who want to find out, what's happening with the games and with their gamers. You can create a proper data modeling, for a new use case for future. And while you have a data which is centrally located in this HTAP system, you can still always, move or archive some of the data, let's say, which is something which you're not using. Let's say year data which is older than 1 year, you can probably move it to data lake, and still integrate that layer with this HTAP layer. You can perform additional complex analytics using Spark, for example, and you can run your Spark codes and again fetch data from real-time HTAP systems. So it's basically typically how the gaming customers would create their architectures. right? So now that we have covered, what and why, let's talk about how do we do HTAP and how is HTAP really done in the industry. And this is where probably, I'll talk about a product called TidyB, and obviously this is, and I don't want to talk uh, any marketing stuff here, but I wanted to basically use this and talk about how TidyB kind of does and supports HTAP workloads. So TidyB is a new SQL database, which basically combines the best of SQL and NoSQL data processing models, and it's a distributed system. If you've again heard about these big data technologies, all of the big data technology we talk about, whether it's Hadoop, whether it's Teradata or Greenplum or Netezza, all of them are distributed, and they're distributed because they ingest lots of data and they expect lots of analytics running and giving you a fine performance. Right? The most important thing, as I was talking earlier, is consistency, right? And these systems must provide ACID guarantees for your queries, and which is probably one of the most important things for HTAP systems. Right? And with TidyB, since this is a HTAP system, it also needs to ingest transactional workloads into it. It does your partitions, it replicates your data, it distributes the data automatically, and it supports the MySQL compatible protocol. Right. So how does HTAP help? Once again, to summarize, it empowers your real-time scenarios. It improves your business agility. It simplifies architecture because now instead of maintaining multiple databases, now you're just maintaining one single data platform. And it would also lower your maintenance cost because now you're only investing into one single platform rather than multiple platforms. Right. So what's a typical architecture of a HTAP system? And this is an architecture of TidyB, which I'm talking about. Right. So in this case, you see that on the left-hand side, there are MySQL clients, which are, let's say, connecting to this TidyB database. The first part of this architecture is called a TidyB cluster. This TidyB cluster holds TidyB nodes, which are a computation nodes. They only perform computation, and they do not store any data. Right? This TidyB layer understands the MySQL protocol. So any existing applications who understand MySQL can directly start connecting and communicating with the TidyB cluster. Now, let's say there's a request which comes for a write. You want to write some data into this cluster. There's on the top, there's something called a PD cluster, which basically is the brainchild of this architecture. Right? The PD cluster is the one which would decide how your data gets stored, how the data is retrieved, how the data gets replicated, how is their high availability maintained, and so on. There are a lot of other features which the PD cluster does. Right? So for writing a data, TidyB would ask PD where to write the data. That PD will send back a response and saying, go and write the data on a particular storage node. Right? Now, in the middle, this is the storage cluster in this architecture, which stores your data. All your physical data is stored here. And there are two components in this. The first one is called TiKV, and the other one is called TiFlash. TiKV basically means that your data would be stored in a key value format, right? And this is where we say that it can support the NoSQL, data formats. And then there's another component called TiFlash, which stores your data in a columnar format, right? Now, if you remember, I just spoke about NewSQL system, and the power of NewSQL systems is that they combine the power of SQL system, which is in this case the TidyB cluster, which understands the complete SQL language, and you combine the power of NoSQL, where you're storing your data in key value pair. And when your data is in a key value pair, your data is a lot more faster in terms of accessing the data and writing the data, right? And at the same time, you also have a TiFlash layer, where you are storing your data in a columnar format. For analytics. So TiFlash is something which is used for analytics, and key value pair is used for transactions. Right? This is where now we combine the transaction and analytical processing onto these storage models. And going further down, talking about the TIE Flash, since we are talking about the edge tab here, if you've heard about this term called MPP, it's basically the massively parallel processing architectures. And again, all these big data, databases, all of them follow this massively parallel processing architecture. And what this basically means, and probably I'll just cite an example. If, let's say, I have a pack of cards and I want to count these cards, let's say hypothetically it takes 1 minute for me to card this complete pack of cards which I have. Now, instead, what I will do is I will split these cards into 2 other friends of mine, right? So now we are 3 of us who are counting these cards. So what will happen? Probably now we may just take about 20 to 25 seconds to count these cards compared to 1 minute earlier. So the job was done. I got to know how many total cards are there, because all 3 of us shared this, activity among each other. We did not share anything among ourselves, right? We all were working on our own. And this is what basically is MPP at a very high level, right? This is how massively parallel processing architectures also do. So they split the data onto multiple nodes, and each node performs its own activities. Each node has its own resources. They have their own CPUs, they have their own memory, own storage. They do not share anything with each other, right? And with this MPP, you get to enjoy and benefit with higher performance for your analytics. So what we did was, with the TiDB, the TIE Flash runs on MPP mode, right? So your data analytics is stored and distributed across your nodes. And where comes the real power of an edge tab system is, when the user does not have to worry, on which underlying storage should I run my query on. So if a user runs a very simple query saying, select from a table, where ID equals to 1, it's a very point select query. It is the role of the TiDB optimizer which basically decides, where should you go and get, or where should you go and fetch the data. So if the optimizer understands, okay, this is just a very simple point select query, let me go and fetch the data from the TiKV nodes, right? Because from the transactional, from the key value stores. And if you write a complex query, where you're doing some aggregation, some joining between the tables, then the optimizer will automatically know that this is probably analytical nature. This query is analytical in nature. So what it'll do is it'll go and fetch the data from your TIE Flash node this time, and not from a TiKV. And in certain cases, it could also be that there's a mix and match, where the optimizer is fetching some data from your TiKV nodes, where there is just point selects, where you just need to fetch some data, and it's performing the analytics on the TIE Flash nodes, right? So this is basically the real power of edge tab, where you are able to first, as I was saying with the transactional workloads. So your transactional workloads will be completely taken care by, let's say, by TiKV, by storing your data in key value. And when we're talking about analytical workloads, your data would always be fetched, let's say, from TIE Flash nodes in this case, right? So this is how underlying architecture is, and how it enables, the edge tab workloads, right? And then there are just, few benchmarks we did, and this is, the reason I've put this slide here is to basically stress out that TiDB is an edge tab system. It's not purely an analytical system, right? It's an edge tab system which brings in transactional information, and then gives that capability of doing analytics. And then we kind of compared it with few others. We compared it with Spark, the open source Spark. We used some versions. We used some MariaDB column stores. We used Greenplum there. And mind you, all these which I've spoken about are mainly analytical systems, right? And not edge tab systems. Probably, we are one of those. So with the results which we achieved from this benchmark, generally we see the one in gray. I think we got great performance in performing analytics on these systems, right? So I think that kind of brings me to an end of this, introduction to HTAP, and I think I'll be open to questions.
Thanks so much, Banu. That was really cool. So I guess I've got a couple of questions that sort of jumped at me during your presentation. I think you mentioned that you've got like a MySQL client for PingCap. Um, is, have you got any plans for other client support, or is that kind of the main client that you sort of work with at the minute?
No, so we have multiple access points. So what I basically meant was that if a customer is already on MySQL, then and if somebody wants to port over, let's say, and want to start using their HTAP system, then they can just bring their code and put it on TidyB. They do not need to do any migrations. But from connection standpoint, it could be any application who can access, as long as they can talk the SQL protocol.
Oh, okay. And so you use the SQL protocol. It's via a JDBC, or like you've got, yeah,
That is
cool.
right. Yeah.
And in terms of sort of like getting up and running sort of locally and stuff like that, you've got like Docker containers and stuff like that. Have you got, similar to the last speaker, have you got like Kubernetes operators, or do you prefer that customers sort of leverage the, the commercial platform and stuff like that?
Oh yeah, so it's a good question. Yes, definitely. So TidyB can actually run on bare metal, on private cloud, on Kubernetes. And we also have something called TiCloud, which is a SaaS offering. So if somebody wants to go and explore TidyB, they can just go and open up their free account on TidyB Cloud, and maybe go and start exploring TidyB.
Yeah, so I guess that's a easy way just to get your hands dirty and get up and running really quickly without having to muck around with instead of trying to deploy it yourself or something like that. Now, that sounds really cool. And then sort of like, what are you seeing sort of customers using like a HTAP database for? You gave us the example of like a gaming company or something like that. Like an idea that popped into my mind was like, say, a call center. They're creating records, but also they like to have those dashboards on average call wait times and things like that, and a call center operator performances and stuff like that. And traditionally, you'd have like a OLTP database and a bit of a delay until you get it to your OLAP and then to your dashboards and stuff like that. Would that be a use case, and any other use cases that you can kind of let us know about?
Oh yes, absolutely. It's a great use case, like as you mentioned, having call centers and bringing the data in real time and then able to access it. There are other use cases which we've done with our customers. For example, talk about logistics. Your data is coming in from the drivers who are kind of on their route. Data is coming in real time, and you want to take analytics, perform analytics on that data, and reroute your drivers on demand, and manage your drivers accordingly and manage your logistics accordingly. It's one of the great use cases which are available. There are payment companies, for example, something like PayPal and Stripe, which would be highly benefited with something like HTAP, because they can actually do an online real-time fraud analytics on the data while the transactions are happening in real time. So these are just some of the use cases for HTAP.
Yeah, sounds amazing. Well, I'm definitely keen to give it a try, and really appreciate you coming on this month to give us a bit of a run through, because it's like it's happy days for data engineering when we don't need to build like hundreds of pipelines all the time. We can just
Absolutely.
use that instead. So thanks once again, Banu, and really appreciate your time.
Thank you, Peter.
Bye. Awesome. So that's it for the November edition of the DataEng meetup here in Australia. We're going to try and get back to in person as soon as possible. Like, restrictions have been lifted. We're all out of lockdown, enjoying our freedoms. Well, most of the country, I guess. And so, yeah, it's just find some venues, get some speakers here in Sydney, Melbourne, and Brisbane, and get meeting in person, enjoying slices of pizza together once again. So thanks so much for your patience in sort of bearing with us, and while we sort of navigate the meetup through the lockdown and things like that. Looks like there's a little bit of light at the end of the tunnel now. It looked like we kind of broken the back of the pandemic, fingers crossed. So we can get back to our regular old lives and sort of getting together as a community once again. We should have some awesome announcements to make as well in terms of, an in-person aspect to the DataEng Bytes conference. So stay tuned for those announcements as well. But in the meantime, keep being awesome and stay safe. We'll see you all at the next meetup. Thanks so much. Bye.